We're looking at Chapter 8, Sinusoidal Functions. We're going to look at Section 8.4. In this section, we'll explore periodic functions again, and we'll look at equations of sinusoidal functions and investigate characteristics such as domain, range, amplitude, midline, period, maximum, and minimum. So let's just go back briefly. We have studied some functions before. In Chapter 5, we studied linear, quadratic, cubic. In Chapter 6, we looked at the exponential function. And in Chapter 7, we looked at logarithmic functions. We also looked at equations and analyzed their equations for these characteristics of the number of x-intercepts, y-intercept, and behavior, domain, and range. Recall that a sinusoidal function, we have the period, which is the domain, how long it takes the domain, the length of the interval of the domain to complete one cycle. So here we have the distance from here to here, to go from maximum to maximum, or from minimum to minimum. It is also twice the distance from maximum to minimum. So if you could determine the max to min, the period would be twice that. We have the amplitude, which is the distance from the midline to the maximum, or the midline to the minimum. And of course, the amplitude will always be positive. The midline is halfway between the maximum and the minimum. And of course, the maximum is the highest point in the y values, and the minimum is the lowest point for the y values. If you're looking at, now we're going to take this equation and we're going to add some variables to it, and it's going to shift graphs. It's going to make the graph a little bit different. It's going to translate the graph, or transform the graph rather. So our period will change, our amplitude will change, our start values will change, our horizontal translation. So we're going to change different things here with this equation to transform the sine graph. And the same thing, we have a cosine graph, and we're going to add variables here to transform the graph of cosine, cos x. So let's go back, just look at the example. We have the maximum here at 3, the minimum here at -7. So the range is going to be in between these two. We have the midline is the middle between these two. In this case, it would be y equals -2. So we have the maximum at 3, the minimum at -7. That will give the range to be -7 subtract, or -7 is less than or equal to y is less than or equal to 3, and y belongs to a set of real numbers. The equation of the midline is going to be y equals -2. The amplitude is the distance from the midline to the vertical distance from the midline to the maximum. In this case, it is 5, 1, 2, 3, 4, 5. And our period is the domain, how long it takes the domain to go from maximum to maximum, or from minimum to minimum, or how long it takes to go from double the amount of time it takes to go from max to min. And in this case, we go from, we could also look from the sinusoidal axis, or from the midline rather, and do a complete, does one complete cycle for 180 degrees. That is the period. So now we're going to investigate the sinusoidal equations of sinusoidal functions. So we have a sine function. We have a, b, c, and d added to the sine x, and we have, this should be cos x rather. Sorry, this should be cos x. Cos x, we have the same. We have a, b, c, and d added. Now, A represents the amplitude, D represents the midline. The minimum value will now be D subtract A, the midline subtract the amplitude. The maximum will be d plus a, the midline, or the midline plus the amplitude. We can determine the period by taking 360 and dividing it by b, or 2 pi dividing it by b for radian measure. And our horizontal translation is c. Now this is very tricky. It's going to help us match some graphs in a few minutes. The horizontal translation is the distance from the vertical axis to the first midline point that is increasing for sine x, but it's different for cos x. It'll be the first maximum point for cos x. So this is very tricky, and we're going to look at this in a few minutes in some examples. So our first example, we have y equals 2 sine 3x. And in this case, our amplitude, of course, equals a. Our amplitude is a. So in this case, our a equals 2 and b equals 3. C equals 0 and d equals 0. So we have our amplitude rather is 2. Our midline will be d, which is 0. So y equals 0 is the equation of the midline. Our period will be 360 divided by 3, which is going to be equal to 120 degrees. And our range is going to be our minimum, which would be less than or equal to y, is less than or equal to our maximum. Y belongs to a set of real numbers. And our minimum is going to be d subtract a is less than or equal to y, is less than or equal to d plus a. Y belongs to a set of real numbers. So in this case, d subtract a is negative 2 is less than or equal to y, is less than or equal to 2. And y belongs to a set of real numbers. So now we can see how we could get the range from an equation. If we draw this graph, we have the period is going to be, I'm just going to sketch here. The period is period to be 120 degrees. And that means that the period divided by 4 will go up by each point. So each point will go up by 30 degrees. And so I'm just going to put 30, 60, 90, and 120. For a sine graph, our first point will be on the midline. So we have 1, 2, 3, and we have -1, -2, -3. And our midline is at 0. I'm just going to change colors here. Midline is at 0. So for a sine graph, our first point is the midline of the 5 key points. Our second point will be our maximum, which is going to be 2. And our third point is going to be the midline again. Our fourth point will be the minimum. And our last point will be the midline again. So if we sketch it, it looks like this. Here we have a cosine function. And when we're looking at a cosine function, our first point will be the max. Okay? Here we have amplitude is going to equal a again. It doesn't change for cosine, so our amplitude will be 3 units. The midline is equal to d. In this case, d is -1. So y equals -1 is our midline. The period will be 360 degrees divided by b. So we have 360 degrees divided by 2, which gives us 180 degrees. And our range, of course, is our minimum. D subtract a is less than or equal to y, is less than or equal to d plus a. And in this case, we have our d is -1 subtract 3, which will give us -4, is less than d plus a, which is -1 plus 3, which would be 2. I'm just going to sketch the graph here. And each point should go up by 180 degrees, as our period divided by 4. Each point should go up by 45 degrees. Now we are going to start at negative 30. So negative 30. And each point should go up by 45 degrees. I'm just going to continue to jump by 30. And since the period is 180 degrees, my last point should be at 150. If I'm starting at negative 30 to go to 150, that would give me 180 degrees for my period. And we have our 1, 2, 3, 4, and we have negative 1, negative 2, negative 3, and negative 4. And so our first point will be our maximum. Our first point is our maximum, and it has to be at negative 30. Just going to change colors. So at negative 30, and our maximum in this case is 2. It'll go 45 degrees to the next point, just for the sketch, because since we're putting in 4 more points from our key point, then they must go up and they all must be inside the 180 degrees. So our next one would be here at 15, and that will be our midline. And our midline is at negative 1. And then the next point will go up by 45 degrees, and we're going to go right to our minimum here. And our minimum is negative 4. So and then we go back to our midline. And then we go right to our maximum again. And here's the sketch. Okay, so let's match some equations. This is a popular question here, a very good question. Matching graphs with the equations, and we have to look at various things here. We have to look for the midline and the amplitude, and especially the horizontal translation, the start value for various ones, and whether they're sine or cosines. So let's just look at graph 1. And in graph 1, we have a maximum of 5 and a minimum of negative 3. And so that would give us, for our midline, that would give our midline at 1. So that'll be, let's just make sure, that's going to be 1, 2, 3, 4. 1, 2, 3, 4. So 4 is our amplitude. Therefore, now in this case, I can cancel out equation number 2, since our amplitude is 4, and every other equation has an amplitude of 4. We also have the midline at 1, so that will also cancel the midline at 1. Each one of these all have a midline at positive 1. So if we look at, let's look for a sine function first. We can look for a, I'm going to look for a sine function first. And sine function, here in this case, it would start at 90 degrees on the midline, and that's not correct. 90 degrees on the midline is the maximum, not 90 degrees on the midline should be on the midline for, cos, for, if I'm looking at cos, looking at the first one, 90 degrees will be its maximum. So 90 degrees will be its maximum. That is correct. And now we have to check for the period. The period of this one that goes from maximum to maximum, which the period of this one goes from 90 to 90 degrees to 210. And so the period of this function, the period of the first function is going to be 360 degrees divided by b, which is going to be 360 degrees divided by 1. So the period of the first function will be 360 degrees. Yet the function in the graph, to go from 90 here to 210, would not be 360 degrees. So I know it's not the first one. So if we continue, let's just go back with cos. Again, let's look at the last function for cosine. Here the start value must be at 60. And if it's where it's cos, its maximum value must be at 60. So we look here at 30, 60. At 60, it's not the maximum value, it's actually the midline value. And so that will tell us that it's not cos, it's not this equation right here. It may be the third equation though. So we start with here at 60, we start at our midline value. And here the period of this function goes from 60 all the way to 180. So that'll be 120 degrees for the period. It goes from here to here. Let's just determine the period of the equation here. And we have 360 divided by b, which equals 360 divided by 3, which will give us 120 degrees, which our equation was 120 degrees. The graph here, the period was 120 degrees. So once again, it's very tricky. Watch for this. It's horizontal translation. For sine, if it starts at 90, or it starts at 60 rather for sine, then that means the first midline point for sine must be at 60. Or if it starts at 90 for this cosine, it must be the maximum point. Let's have a look at the second equation. This one, of course, will be equation 3. Let's have a look at the second equation, or the second graph. We have a maximum of 5 and a minimum of -3, giving us the midline will be 1 again. So in this case, I'm going to change color here to blue. In this case, this equation is gone again, equation 2. Since the midline here, the midline is y equals 1, and this one has a midline of 0. So we have, we've already used equation 3. So we're going to have a look at the first equation here now. So it must be a start value at 90, and the start value must be a maximum because it's cos. The start value will be at 90, and it must be a maximum because it's cos. So here at 90, we do have a maximum. So at 90 degrees, we do have a maximum. That's great. If now the period is 360 degrees, according to this equation, the period of this function is 360 degrees. So if we have a period here of 360 degrees, we are good. So we go from 90 right to 450. From maximum to maximum, it goes from 90 to 450, which is 360 degrees. So we have, this one will be equation 1. If you wish, we're going to do another equation, another matching the graph of the equation here now. If you wish, you could pause the clip and attempt it on your own. I will continue. We're going to look at the midline first of the graph A, and we have 3 and -7 is our minimum. So our midline equation will be at y equals -2. In this case, equation number 1 is gone since the midline equation of this one is 0. So now let's look at equation number 2. This would tell us that we have an amplitude of 5, so that is right, 1, 2, 3, 4, 5. Of course, all others have an amplitude of 5 as well. Here we have a start value. The horizontal translation is at 30 degrees. And since it's cos, that means the maximum must be at 30 degrees. So if we look at 30, 60, 30 degrees, we do not have the maximum. We do not have the maximum showing up at 30 degrees. So here at -75, we should have a maximum, and -75 is not shown here. We should have a maximum. Let's try the last equation. At 30 degrees, we should have a midline value. At 30 degrees, we should have a midline value since it's sine. So we have at 30 degrees, yes, we do have a midline value. So let's just check the period. So we go from 30 degrees right to 210. So 30 degrees to 210. 30 degrees to 210. And this will give us a period of 180 degrees. So let's see if equation 4 will give us a period of 180 degrees as well. We take 360 and divide it by 2, since 2 is our b, which gives us 180 degrees. So yes, graph A will be equation 4. Now, I'm going to switch colors here. Let's look at graph B. Once again, we have a midline at -2. And here we cancel out equation 1 again. So we also have equation 4 gone since we've used it already. So now we have 2 cosine equations to check. We have here at 30, there should be a maximum value. At 30, so we got 30 degrees right here, and yes, it is a maximum. Now, here it goes from 30 degrees right to 210. The period goes from 30 degrees to 210 for our period. So let's calculate what the period of this function will be, and that will be 360 divided by 2, since b is 2, which will give us 180 degrees, which this function went from 30 degrees to 210, which is 180 degrees as well. And so we have graph B will be equation number 2. So we have another example here for match the graph with each corresponding equation below. I'll leave this one for you. I will, however, tell you that graph A is equation 5 and graph B is equation 2. So be aware now, watch what when you're choosing your start value, your horizontal translation. Here this would have to start at -30 degrees, and it would have a maximum at -30 degrees. This one would have have a maximum value at 120 degrees. So be careful here. The height of a chair on a Ferris wheel is described by the function h of t equals 15 cos. So to t subtract 1/2 plus 18. So here, this 1/2 shows us we're in radians, where h of t represents the height in chair meters and t represents time in minutes. What are the maximum and minimum heights you can reach if you are riding the Ferris wheel? So of course the maximum will be d plus a, and in this case d is 18 and a is 15. So the maximum will be 33 meters. The minimum is d subtract a, and here d is 18 and a is 15, which will give us the minimum is 3 meters. What is the period of the function? And the period of the function will be, since we're in radians, we have 2 pi divided by b, and that will give us 2 pi divided by our b here is 1, which will give us 2 times pi, which is about 6.28 or approximately 6.3. So the period is 6.3 minutes. What does the period tell you about the Ferris wheel in this context? It tells us that it takes 6.3 minutes to do a complete revolution of the Ferris wheel, to go in one complete cycle of the Ferris wheel, complete revolution of the Ferris wheel. So in summary, we have characteristics for a sine equation. The amplitude is a, of course. The equation of the midline is d, right here. The maximum value is the sum of the value of the midline and the amplitude, so d plus a will be the maximum. The minimum value is d subtract a. The range is the minimum is less than or equal to y, which is less than or equal to the maximum, and y belongs to a set of reals. The horizontal translation from y equals sine x is c. So when you have this c, remember if you have sine, the first value will be at c, will be a midline value. If it's a cosine graph, the first value at c will be a maximum. And here we have the period is 2 pi over b, or if you're in degrees, it will be 360 degrees over b.